Previously, we explored the smallest to the largest black holes in the universe. This time, we're expanding our scope, comparing all kinds of cosmic bodies across the universe, from tiny objects to grand cosmic structures. We'll reference material from the web and break them down one by one. First up, Ceres, the ancient god star. Ceres, also called the ancient god star in Chinese astronomy, is a dwarf planet located in our asteroid belt. Its diameter is less than 1,000 kilometers, tiny on a cosmic scale. From this image, you can see just how small Ceres is. Even our moon dwarfs it by a huge margin. But don't underestimate it. Ceres is still the largest object in the asteroid belt. Most other asteroids are too small to even form a proper spherical shape. 2. Next, Makemake, the bird god star. Another dwarf planet, Makemake, located in the Kuiper belt beyond Neptune. It's the fourth largest known dwarf planet in our solar system, and, fun fact, it even has its own moon. Also, its name isn't pronounced Makemake. It's Maki, from the mythology of Easter Island's native people. 3. Pluto, the fallen giant. Our old friend, Pluto. Ever since it was removed from the list of major planets, Pluto has been the flagship representative of the dwarf planet category, once a planet, now a legend. 4. Europa, the ocean moon. Next is Europa, Jupiter's moon. Europa has a silicate rock core wrapped in a shell of water ice, with a surface so smooth it has barely any mountains or large craters. It is often called the smoothest world in the solar system. Beneath its icy crust, scientists believe a vast liquid ocean may exist, making Europa one of the best candidates for extraterrestrial life in our solar neighborhood. 5. Our familiar companion, the moon. Then comes Earth's loyal companion, the moon. As you can see, it's even larger than Europa and ranks as the 5th largest natural satellite in the solar system. Why does our relatively small Earth have such a large moon? That leads back to the ancient mystery of the moon's formation, which we've covered in a previous episode. 6. Mercury, the smallest planet. Next up, Mercury, the smallest planet in the solar system. It's so small that some scientists speculate it might be the stripped core of a once giant gas planet, its outer layers torn away by the sun. Is that theory true? We explored this in our episode, The Mystery of Mercury's Iron Core. Check it out if you're curious. 7. Titan, the methane world. Now, we arrive at Titan, Saturn's largest moon and the 2nd largest moon in the solar system. Titan has a dense nitrogen atmosphere, thicker than Earth's. However, it receives only 1% of Earth's sunlight, and after passing through that thick atmosphere, less than 0.1% reaches the surface. Temperatures plunge to around 180 degrees, so the lakes and seas on Titan are not made of water, but liquid hydrocarbons like methane and ethane, a truly alien world. Next up is Mars. As a planet also located in the habitable zone, just like Earth, people have high hopes for Mars. After all, although its average temperature of -63 degrees Celsius is a bit cold, it is already much better than other planets. Although Mars is very similar to Earth, if we're talking about the planet most similar to Earth, it would have to be Venus. Venus is not only similar in size to Earth, but also has a dense atmosphere. However, Venus's atmosphere is excessively thick, and over 96% of it is carbon dioxide, so the greenhouse effect here is extremely exaggerated, with surface temperatures hot enough to melt lead. By the way, Venus should actually appear white. Is it the great white star of myth? Pictures of Venus that show it as orange-yellow are actually what it looks like after its atmosphere has been filtered out. Next, Earth. Oh, isn't it similar in size to Venus? There's not much to say about Earth, so let's just skip it. Next is an exoplanet, Kepler RRB. Kepler RRB is also a planet located within its star's habitable zone. Since it was discovered using the transit method, we don't know much about its mass. We only know that it is considerably larger than Earth. So, whether it's a gas giant or a rocky planet, or even an ocean planet covered in liquid water, it's still hard to say. Next, we return to the solar system. It's Neptune, the farthest planet from us. As an ice giant, Neptune's atmosphere is primarily composed of hydrogen and helium. It is also the place in the solar system with the strongest storms, featuring supersonic winds reaching speeds of 100 kilometers per hour, combined with temperatures of 1 to 200 degrees below zero. This feeling, as Neptune's twin brother Uranus is not only a bit whiter in color, but its temperature is also the lowest among the 8 major planets, making it quite aloof or cold. However, its axial tilt, causing it to lie down and rotate, is truly like a mischievous child. Finally, it's the gas giant's turn. First up is Saturn. Saturn's most obvious feature is its beautiful planetary ring. Saturn's rings are very prominent. In the 17th century, Galileo was already able to observe some features with his self-made telescope, although he didn't realize it was a ring. Then there's Jupiter. As the big brother of the solar system's planetary lineup, Jupiter is not only massive in size, but also in mass. Jupiter alone has more mass than all the other planets combined. But no matter how large a star, it is dwarfed in comparison to truly massive stars. The Sun's mass accounts for 99.86% of the total mass of the solar system. It's no exaggeration to say that all other celestial bodies in the solar system are merely leftovers from the Sun. However, even the powerful Sun has to bow down when facing Sirius. Sirius is actually a binary star. What's shown here is Sirius A, which has 2.1 times the mass of the Sun, while Sirius B is a white dwarf. The next star to appear is called Capella. Capella is a B-type star with 5 times the mass of the Sun, and its luminosity is 700 times that of the Sun. It has already entered the late stage of stellar evolution and is developing into a red giant. Next to appear is a red giant, Pollux. Because Pollux is already in its late evolutionary stage, although it only has twice the mass of the Sun, its radius has expanded to 9 times that of the Sun, equivalent to the size of over 700 suns. Next is another red giant, UY Scuti. UY Scuti appears much larger than Pollux, but its mass is only comparable to the Sun's. One can imagine how puffy it is. All right, now it's finally time for black holes to appear. First to appear is the supermassive black hole closest to us, Sagittarius A at the center of the Milky Way galaxy. Previously, during the Nobel Prize ceremony in 2020, it was cautiously referred to as a compact object. But less than 2 years later, with the release of Event Horizon Telescope, ERT images, it's basically confirmed that the center of the Milky Way is a supermassive black hole. The diameter of Sagittarius A is about 4 to 4 million kilometers, nearly 0.3 astronomical units. If placed at the Sun's position, it would basically already be close to Mercury's orbit. However, in terms of size, Sagittarius A is not considered large. It's still far smaller than some stars, such as Aldebaran, which appears next. Stars of this size are generally giants in the late stages of evolution. Aldebaran is such a red giant. Although its mass is comparable to the Sun's, its radius is already 44 times that of the Sun, equivalent to over 80,000 suns. Next is another giant star, Mu Cephei. Although Mu Cephei is also a giant star, its color is bluish, classifying it as a blue supergiant. These types of stars are originally very massive, and being in the late stages of evolution, their size naturally speaks for itself. However, Mu Cephei has only just entered the category of blue supergiants. When facing certain other stars, even blue supergiants instantly lose their luster. For example, the Pistol Star. The Pistol Star is a blue hypergiant. Not only does it have 27.5 times the mass of the Sun, but it also has a radius exceeding 300 times that of the Sun. Astronomers believe that in an outburst several thousand years ago, the Pistol Star ejected approximately 10 solar masses of material. Its stellar wind is 10 billion times that of the Sun. It is expected that in the next 1 to 3 million years, it will end its life as a supernova or hypernova. It's not that blue giant stars are necessarily larger than red ones. Blue supergiants can also continue to evolve into red supergiants. For example, the red supergiant Nubi 2, mentioned below. Nubi 2 has a mass of approximately 15.5 times that of the Sun and a radius of 680 times the Sun's radius, which is equivalent to 300 million suns in terms of volume. If it were placed in the Sun's position, it might even cover the asteroid belt. Next, we formally enter the red hypergiant classification. First up is VY Canis Majoris. As a hypergiant, VY Canis Majoris has a mass of about 30 to 40 times that of the Sun and a radius of 1,400 times the Sun's radius. If it were placed in the Sun's position, it would even cover Jupiter's orbit. Next up is the famous UY Scuti. Many people have probably seen this comparison chart. Compared to UY Scuti, all red giants and red supergiants are insignificant. Although UY Scuti once held the top spot as the largest star, there's always something bigger. Soon, the title of largest star was taken by another red hypergiant, Stephenson 218. Stephenson 218 is located in Stephenson 2, a young open cluster. This cluster contains many red supergiants, which is why it's known as the red supergiant cluster. Stephenson 218 is the most representative among them, with a radius reaching 2,150 times the Sun's radius, equivalent to 10 billion suns in terms of volume. All right, now stars are no longer the largest. It's time for supermassive black holes to make their appearance again. S5 or Tau 4 plus 81 is an active galactic nucleus or quasar located 12 billion light-years away from us. Through calculations, astronomers believe the black hole at the center of this quasar has a mass of about 10,000 times that of the Milky Way's central black hole, which is 40 billion times the mass of the Sun. Such an enormous mass gives it a radius of 800 astronomical units. We can no longer use the Sun's radius as a unit. What does 800 astronomical units mean? It's 800 times the distance from Earth to the Sun, which is 20 times larger than Pluto's orbit. However, the largest confirmed black hole to date is TON 618. Also a quasar, the central black hole of TON 618 has a mass of about 66 billion times that of the Sun, with a radius reaching 1,300 astronomical units. All right, now that the largest stars and largest black holes have made their appearance, it means the size of single celestial bodies has reached its limit. Next, the stage belongs to those loose structures, nebulae. First up is the Helix Nebula. This is a planetary nebula located just over 600 light-years away from us. About 10,000 years ago, a sun-like star ended its life in an explosion and produced this nebula. Today, the nebula's radius has exceeded 1 light-year and is still expanding outwards at a speed of over 30 kilometers per second. Next is the familiar Lagoon Nebula. The Lagoon Nebula is a dark nebula located 1,375 light-years away from us. It is part of the larger Orion Molecular Cloud Complex, with a radius of about 3.5 light-years. Next is the Eagle Nebula. This nebula is an active star-forming region with a radius of nearly 5 light-years. The pillars in the middle are the famous Pillars of Creation. Next is a dwarf galaxy. It is one of the smaller satellite galaxies of the Milky Way, with a radius of only 100 light-years. Next is another nebula, but it's not a nebula in the Milky Way. This is a nebula located in the Large Magellanic Cloud, the Milky Way's largest satellite galaxy, and it's called the Tarantula Nebula. The blue bright light in the middle of the Tarantula Nebula is a star cluster, R136, with a diameter of 35 light-years, containing numerous blue giant stars. The most massive known star, R136A1, is one of its members. Next is the Sleeping Beauty Galaxy, also known as the Black Eye Galaxy. At first glance, this galaxy appears to be an ordinary spiral galaxy, but it was later discovered that the direction of motion of its outer material is opposite to that of its interior. It is speculated that it recently swallowed a satellite galaxy that collided with it. Next, let's talk about our galaxy, the Milky Way. Regarding the actual diameter of the Milky Way, some say 100,000 light-years, others say 200,000 light-years. Recent research from the past 2 years even suggests nearly 2 million light-years. This is actually similar to asking how big the solar system is. It depends on what standard you use. Is it the Kuiper Belt, where Pluto is located, the heliopause, where the solar wind can reach, or the hypothetical Oort cloud, based on gravitational influence? Usually, when we talk about the size of the Milky Way, we are referring to the obvious galactic disk made up of stars, gas, and dust, which has a diameter of 100,000 to 180,000 light-years. After discussing the Milky Way, it's time for the largest galaxy in our local group, our neighbor, the Andromeda Galaxy. Whether in terms of mass or size, the Andromeda Galaxy is much larger than our Milky Way. Because its spectrum shows a blue shift, scientists infer that the Andromeda Galaxy is approaching us at a speed of hundreds of kilometers per second. In approximately 3 billion years, these two galaxies might merge to become the Milkomeda Galaxy. The merged Milkomeda Galaxy might be an elliptical galaxy. However, in the family of elliptical galaxies known for their colossal size, Milkomeda would only be a minor player. The true behemoth would have to be IC 1101. IC 1101 is currently the largest known galaxy, though its size is still debated. That's enough about galaxy sizes. Next, it's time for galaxy clusters to take the stage. First up is the Virgo supercluster, also known as the local supercluster, where we are located. This is a supercluster containing our local group, composed of hundreds of galaxy groups and galaxy clusters with a diameter exceeding 100 million light-years. At this scale, our Milky Way is truly located in a remote suburban area. Although the Virgo supercluster is enormous, it is also part of an even larger structure, the Laniakea supercluster. Laniakea encompasses 300 to 500 galaxy clusters and galaxy groups. totaling approximately 100,000 galaxies. This is only what has been observed. As a large-scale structure spanning 520 million light-years, Laniakea might not be entirely gravitationally bound. That is to say, the galaxy clusters within it might just appear close together, but in reality the structure as a whole is not stable. In fact, gravitationally bound structures in the universe generally reach this scale. As for those galaxy great walls stretching billions or even tens of billions of light years, they are actually artificial hypothetical structures that cannot be held together by gravity. So, what is the largest known hypothetical structure? That's right, it's the observable universe centered on us, spanning 93 billion light years. All right, this is Lingmo talking about the universe, making the universe easy to understand. See you next time. Bye-bye.